Hello everyone, welcome to the another lecture in the series of electric circuits. We are now going to talk about electric power. So one of the most important functions of current in an electric circuit is to transfer energy from a source to an electrical device. So let's say you are trying to charge your phone, okay? So you put it on charger. So the most important function um, of current is to transfer the energy from the battery towards the device. Okay, so the positive terminal of the battery is connected by a wire to the terminal that is labeled as A. So the bigger line over here is positive terminal, and this is a negative terminal, the smaller line, and it is connected to the terminal B. Okay, so the battery will maintain a constant potential difference between these terminals, which is A and B. Okay, so let's see what we have next in electric power. So when we an amount of positive charge, that is delta Q, it moves from the higher potential terminal, which is A, towards the lower potential B, its electrical potential energy decreases. Okay, so when the charge starts to flow right from the positive side, the electrons are leaving, right? The charge is flowing. So what will happen? The electric potential energy will begin to drop. So I'm just saying potential energy will drop. So in accordance over here, because we are talking about charges, so the potential energy will be given as the multiplication of Q and V. Okay, charge multiplied by voltage. Okay, so if you have delta Q, then you can put it as delta Q. And if I talk about the uh, energy change per unit time, okay, energy change per unit time, that means E upon T. So I put T over here. So energy per unit time is also known as power. So we call it as power. So let me just show you. So change in energy upon time is power. Okay. And if we elaborate in the term of formula, so it will go as delta Q times delta V upon delta E T. So if you collect this delta Q and delta T, okay, so what is Q upon T? It is current. So you can also write it as I. So P is equal to IV or VI. So this is a formula of power, okay? So you can know that. And if you talk about the units, so the power is measured in the units of watt, okay? And let's say I write 50 meters, I will write like this, and 50 watts will be written like this with capital W, okay? So power is measured in watts, and this is how we write it. And then when the charge moves through the device, the charge loses electric potential energy. Okay, potential energy is basically, let's say there is a battery over here, and then the charge is leaving this, right? So it was sitting here nicely, nice and calm, and suddenly someone, let's say you're sitting over here, and someone say, "Can you do me a favor? Can you bring me a glass of water?" So your potential energy will start to decrease because your energy is now converting into kinetic energy. So the principle of conservation of energy tells us that decrease in the potential energy will be compensated by transforming the potential energy into some other form, right? It will be accompanied by the transfer of energy over here to some other forms. For example, it can appear as light energy. Let's say you are charging your phone, so it will start to display. Earlier it was switch off, right? So this decreasing potential energy will start to appear over here in this device in the form of some other energy, right? Some sound you're listening, right? Or you start to feel your phone is getting warm, okay? And things like that. So this is conservation of energy, right? And here a quick peek into, on the formulas. We can rewrite them in different forms using the Ohm's law. V is equal to IR. So So B is equal to IV, we just studied. So instead of V, you can write IR depending upon the question, what piece of information is given. Let's say you're just given current and resistance and they're saying, can you find P? Then in that scenario, you will replace this V with IR, okay? So you will be using I square R. And then let's say in some other question, you're only given V and R, okay? So in that scenario, you will do this thing, you will take this I and you will replace it with V upon R, right? So you will write V upon R over here instead of I, and then you have V. So basically your formula will be V square upon R. So these are some different forms of power, right? Depending upon what piece of information is given to you in the question to solve. So let's see, here's one problem. So the question says in a flashlight, the current is zero point 0.4 amps, voltage is given, find the power delivered to the bulb. So simply for doing the A part, power, I'm given current, I'm given voltage, so I can simply use VI. So voltage is 3 and current is 0 0.4, so that gives me 1.2 watts as my answer. This is the answer for the A part. And then they're saying for the B part, the electrical energy dissipated in the bulb in 5.5 minutes of the operation. Can you find the electrical energy? So you will say, yes, I can do that because I know power is equal to energy dissipated upon time. Because here I'm looking for energy, so I would like to isolate that. So energy will be P into T. Power, I just found out it was 1.2 and then it is saying 5.5 minutes, and you would like to convert it into seconds, right? So yeah, this is what you will do. Let me punch in the numbers for you. 1.2 times 5.5 times 60, it gives me 396, okay? Or simply you can write 3.96 into 10 to the power 2, or you can just write 396, it's your wish. And because this is energy, it is measured in joules, right? So moving on to the next thing, if you talk about the monthly bill that you pay, let's say in at your house, they specify the cost for the energy consumed during that month, right? So energy, because you just saw it is multiplication of power and time. So companies, what they do, they compute your energy consumption, how much you are consuming that, by expressing power in kilowatts and time in hours. So power will be measured in kilowatts because you are using a lot of power. So watt is a very small scale, so we like to use kilo. Kilo stands for 10 to the power 3, okay? So kilowatts, it makes the watt 1000 times bigger, right? And then time, because seconds will be also very small unit, they like to deal with hours, so kilowatt hour. So they will report your energy consumption in kilowatt hour, okay? Where kilowatt is the power and hour is the time, okay? And let's take one example. If you are using a power of 1440 watts at your place, or in other sense 1.44 kilowatts. Okay, so I moved to 3 decimal places over here, and then I can report it in kilowatts. And then this is a monthly bill, let's say, that contains 30 days. And because you're talking about hours, so 30 times 24, that would be 20, sorry, 30 times 24, 720, right? So that would be 720 hours, right? So you are using 1.44 kilowatts for 720 hours. So your energy consumption will be given by multiplication of power you're using times the 720, okay? And that would give you 1040 kilowatt hours. Kilowatt hours. Okay, excuse me. And then if let's say you have to pay the bill now. The company decides for every 1 kilowatt hour, the customer has to pay $0.12. So how much you are paying? So what you will do, you will take the number 1040 kilowatt hours and then you'll multiply, right? It's like the cost of one chocolate, it's 10 cents, but then you bought 1040 chocolates. So you'll simply multiply because the cost for 1 kilowatt hours. You are using 1040 kilowatt hours. So you times them to see how much bill you are going to pay. So that would be roughly $125 will be your monthly bill for that time frame, right? And now let's say on exam I say or your teacher says, can you convert 1040 kilowatt hours to joules? How many joules they would be? So you will say, yes, I can do that because I know 1 kilowatt hour is equal to 3.6 into 10 to the power 6 joules. Okay, so you should be knowing this and then you should be fine over here. Okay, now next is alternating current. I'll cover that in the next video. Thank you so much for watching.